Hello everyone. In this lecture, we will talk about some famous machine learning and deep learning frameworks, namely Tensorflow, Keras, and PyTorch. Writing code for different data science tasks is not straightforward and requires expertise. However, we have open access frameworks available that make the implementation much easier. They provide us a very rich set of libraries and inbuilt modules that help us implement any complex programming assignment. So in this lecture, we will briefly discuss about some important components of these frameworks. Let's start. If you remember, in the earlier lectures, we have talked about some famous machine learning libraries, especially scikit-learn, focus on this one, matplotlib for visualization purpose, and we also have seaborn that is also used for visualization purpose. Now, like these libraries, we have more advanced libraries as well that we'll discuss in today's class. These libraries are TensorFlow, Keras, and PyTorch. TensorFlow and Keras were developed by Google, while PyTorch is developed by Facebook. Let's discuss each one of them one by one. So let's start with TensorFlow. TensorFlow is an open source software library for numerical computation using data flow graphs. So they are also called computation graphs. TensorFlow was developed by Google for primarily the purpose of conducting machine learning and especially deep neural networks research. However, it is flexible enough to be used across a wide range of other scientific domains as well. At its core, TensorFlow allows developer to create a data flow graph. Now, these are structures that describe how data moves through a graph or a series of processing nodes, where each node in the graph represents a mathematical operation and each connection or edges they are represented between nodes in a multi-dimensional array, which we also call a tensor. That's why the name TensorFlow. How this multi-dimensional data array, a tensor, is flowing from one node to another node. So TensorFlow utilizes a system of multi-dimensional arrays, also called tensors, which serve as the foundation for building and training various types of neural networks. Now, we have not discussed neural networks yet. We will discuss that in subsequent weeks lectures. But TensorFlow and Keras and PyTorch, they are primarily designed to build these very big complex neural networks, the theory of which we will discuss later. So let's try to understand the mechanics of a computation graph or data flow graph with the help of this example. Let's say we want to do this piece of code, we want to run that. We start with some variables, some default values to them. Here we are calculating z1 as their product and z2 as their addition, adding x and y together. Finally, we have this extra variable answer, which calculates the division between the multiplication of x and y and addition of x and y. Finally, we print what is there in answer. Now, typically it is a sequential process, right? It starts from top and it goes to down the last statement, one statement at a time. So for example, first of all, the value 10 is assigned to x, 20 is assigned to y, then the multiplication takes place, then the addition takes place, then we do the division, and finally we print that. However, if you build the computation graph for the same, it works like this. So initially you have values 10 and 20, which are assigned to x and y. So x carries the value 10, y carries the value 20, And there are two operations. One is multiplication. So using x and y, we are calculating their multiplication. And also we are calculating their division. Now, if we write the code, then this process is sequential. First we calculate the multiplication, then we calculate the division. But with the help of this graph, you can see that multiplication and addition, they are not dependent on one another, and they can take place simultaneously at different machines, at different CPUs if possible. Finally, their results are combined and they are divided, Z1 divided by Z2, and after division the answer is finally printed here. So if we look at this example, we can see that computational graphs, they exclusively specify the dependencies across the operations. In other words, how would the output of these operations flow from one operation to another operation? So in this case, the nodes here even print all of them, they represent operations, and all the ages like this here, this or this, and even answer, all of them, they represent data which we call tensor, which is usually multi-dimensional data. That's why the name TensorFlow. Now this kind of computation graph allows for parallelism or dependency driving scheduling. That is, if we look at our computational graph here, we see that we could execute the multiplication and addition in parallel. That is because these two operations do not depend on each other. So we can use this topology of the graph to derive the scheduling of operations and execute them in the most efficient manner. For example, we can use multiple GPUs on a single machine, or even distribute the execution across multiple machines. Now, TensorFlow does exactly this. It can assign the operations that do not depend on each other to different cores with minimal input from the person who actually writes the program, just by constructing a directed graph. Another key advantage is the portability. The graph is a language independent representation of the code. It does not depend on any language. So we can build the graph in Python, maybe save it, and then restore the model in a different language, say C++. So this gives you this extra benefit of portability. Now TensorFlow, PyTorch, they rely on this type of computation graph. We also call them data flow graph. Now let's talk about some major components of TensorFlow. They are the core API of TensorFlow, very useful, Keras API, data API, estimator, TensorBoard, Lite, and there are other components of TensorFlow as well. So let's talk about them one by one. TensorFlow core API is the foundation of TensorFlow, providing complete control over models and workflows. It allows for the creation of computational graphs and the execution of neural networks that we'll discuss later, with highly detailed customization. That is, once you make a neural network, you can do lots of changes in that. It is highly customizable. The next one is Keras API. It is integrated into TensorFlow as tf.keras, we write it. It provides a high-level neural networks API that is user-friendly and modular. It makes it easier to construct, train, evaluate, and even deploy machine learning models. The data API is used for building scalable input pipelines to feed data into models. That is, when we supply data to the model, it goes through certain process which is called the pipeline or input pipeline. So data can handle complex data loading from different sources. It can pre-process the data. It can transform the data very, very efficiently. The next is estimator. It is once again a high-level API of TensorFlow that provides fully fledged model training capabilities. It simplifies the process of model training, evaluation, prediction, and even exporting the model. TensorBoard is a visualization toolkit available in TensorFlow that allows you to visualize matrices such as how models, loss, and accuracy and other performance measures evolve over time. It helps you view the computational graph. It helps you analyze the tensors or the data, multidimensional data that is flowing through the graph, and much more. We also have TensorFlow Lite. It provides tools to convert TensorFlow models into an optimized format, reduced size, so that it can run on devices like mobile and even embedded devices. There are other components also of TensorFlow, such as TensorFlow Extended. It is an end-to-end platform that enables the deployment of production-ready machine learning pipelines, and it ensures that models can be trained and served at a scale. So these are some major components of TensorFlow. Now, often when we use TensorFlow, we abbreviate it with TF. So we often import TensorFlow as TF, and using TF, we can call its component. Keras is a very common component that we often use. We sometimes import data sets like MNIST data set and other data sets. We can directly import it using TensorFlow. We can also create different type of machine learning, deep learning models. In this specific case, we are importing a sequential model. Now, what do we mean by these terms like models and sequential? We will discuss that later. What do we mean by layer here? What do we mean by Adam here within the optimizers? So all these are terms we have not discussed yet. They are very specific to machine learning and deep learning, and in the later weeks we will discuss these terms. But the thing is, their implementation is quite complex. But using TensorFlow, we can directly import that into our code, and we can directly use them as a module, as a function. We need not to write all the code from the scratch. Now let's discuss about Keras. Keras is an open source neural network library written in Python, and it is designed to enable fast experimentation with deep neural networks. Keras provides a high-level and very user-friendly API to construct, train, evaluate, and deploy machine learning models. Keras was developed with the aim of allowing for fast and easy development of deep learning models. You should know that initially Keras was developed as an independent neural network library, and it could run on top of several different other deep learning frameworks, including TensorFlow, including Microsoft Cognitive Toolkit. However, after TensorFlow 2.0, which is the second version of TensorFlow, Keras was integrated directly into the TensorFlow, which makes the making the Keras an official high-level API for TensorFlow. So initially, both of them were separate. After TensorFlow 2.0, Keras has been integrated into the TensorFlow. Now, this integration means that Keras is now specifically optimized for TensorFlow. It takes all the advantages of the TensorFlow's features and capabilities while it still maintains its own concise and accessible interface. This makes TensorFlow not only a comprehensive platform for machine learning and deep learning, but also accessible for beginners, and it has become very efficient for research as well as for production tasks. So when people often talk about TensorFlow integrated with Keras, they know that this whole thing is very comprehensive and provides all the necessary components that are required to build and even deploy machine learning and deep learning models. So within Keras, we have these major modules. So we have the models, we can define different models, we can define different layers, different types of optimizers are there, different loss functions are there, matrices are there, and this functionality of callbacks is also there. Now, all of them, once again, are very specific to machine learning and deep learning, but just let's go through them once to understand some picture about what do we mean by all these terms. So models, within models, Keras provides two main types of models: sequential model and the functional API. The sequential model is the very commonly used model in machine learning and deep learning, and it represents the linear stack of layers and used most commonly in deep learning tasks. Here, layer means the building blocks of neural networks in Keras. Keras offers a wide variety of layers, including dense layer, convolutional layers, recurrent layers, batch normalization, dropout. So there are many types of layers. Now each layer has a very specific functionality that we'll discuss in the later lectures. Then we have the optimizers. So Keras provides access to different optimization algorithms that are used in the training of neural networks, such as uh, stochastic gradient descent is there, Adam is there. There are many, and this will also come later. We have different types of loss functions. So we have functions like categorical cross entropy for multi-class classification. We have mean squared error for regression tasks. We have binary cross entropy. So all these loss functions, they are used for specific tasks. We also have many performance measures, matrices related to neural networks, such as accuracy, precision, recall, F1 score. This is once again something that we'll discuss later. One of the beauty of Keras is the this callback option. So callbacks are a set of functions to be applied at given stage of training process, and we can use these callbacks to save the model, adjust the learning rate, and perform custom actions while the model is being trained. Means during the training itself, we can change the hyperparameters of the models. So these are some of the major components of Keras, and we have already seen how we usually import Keras, but using TensorFlow, we first import Keras, and within Keras, we have access to like sequential model, different type of layers. Dense is one of that layer, flattening layer is there, and there are other options also available in Keras. Then we have PyTorch. So PyTorch is an open source machine learning library developed by Facebook, and it provides a flexible and very intuitive framework for building and training deep neural net models. It is particularly favored for its ease of use, dynamic computational graph, and strong support for GPU acceleration. And it is very popular among researchers and developers for a wide range of applications, from computer vision to natural language processing to reinforcement learning, generative models. So PyTorch is very famous as well, just like TensorFlow. So within PyTorch also we have major functions which are also very similar to TensorFlow, in fact, and we have the concept of tensors here, multi-dimensional data. So tensor are similar to NumPy arrays, but with additional capabilities to be used on GPUs. So support of on GPU is one of the key feature of PyTorch, and that's why people often prefer that. And within tensors, they are the fundamental building blocks that carry data in PyTorch. We also have the auto-grad module. So it is in neural networks, we have to do lots of calculus, right? Especially the differentiation or calculating the derivatives, which is not easy actually for neural networks. It is much complex, this process of calculating derivatives and all. But in PyTorch, we have AutoGrad module, which provides automatic differentiation for all operations of tensors, and that's why it is a key component of training the neural networks. We have the NN module or neural network module, It contains the details of layers, and it provides a very simple way to create and train neural networks. It also includes predefined layers, loss functions, optimization algorithms, and many other components. Then we have the Optim module. So just like in TensorFlow, here also we have a separate module for optimization algorithms like ADAM, like stochastic gradient descent, and etc. There are many. Then we have data sets and data loaders. So for loading the data or transforming it, sometimes we need that, or batching it into the training. PyTorch provides this data set and data loader classes, and they help in loading the data, applying different types of transformation, pre-processing, and finally that data can directly be then supplied to the machine learning model that we are considering. CUDA support is another very important feature of PyTorch. So PyTorch provides this seamless CUDA integration to run computations on GPUs for fast computing. CUDA is actually a parallel computing platform and programming model developed by NVIDIA especially for GPUs. Okay, so CUDA support is another very important part of PyTorch framework. Now, if we compare both of them, majorly TensorFlow integrated with Keras and PyTorch, there are a few differences, and you might be confused initially that whether I should use the PyTorch framework or TensorFlow framework. So these are some comparison points, but both of them are equally good and equally popular among the researchers. So in the case of PyTorch, it uses a dynamic computation graph, meaning that the graph is built on the fly as the operations are performed, so it is not static. This allows for more flexibility and ease in making changes to the network architecture, and it helps in debugging, and it gives the computational graph this additional benefit of knowing the situation, then preparing the computation graph. TensorFlow, on the other hand, traditionally used a static computation graph, which requires the user to define the entire graph before running the model. However, with the introduction of TensorFlow 2.0, the upgraded version, TensorFlow now also supports dynamic computation graphs, and in that aspect, it makes they both of them have become much similar to one another, PyTorch and TensorFlow. Another criteria could be the API style. So PyTorch is often praised for its simplicity and Python-like style, making it easy for Python developers. Its dynamic graph once again makes it particularly suited for academic research and prototyping. On the other hand, TensorFlow and Keras, they offer a comprehensive ecosystem that include not just model building and training, but also tools for deployment, production, experimentation. And Keras being an integral part of TensorFlow now, it simplifies model development with high-level constructs. For both of them, there are large active communities for both PyTorch and TensorFlow in academia and industry also. And TensorFlow's ecosystem is more extensive though, providing a wide array of tools for different stages of model development and deployment. PyTorch, on the other hand, has gained significant attention among researchers due to its flexibility and ease of use. So both have competitive environment, and some people prefer PyTorch, some people prefer TensorFlow. Often in PyTorch, you will find instructions like this. So importing PyTorch, and from Torch you can use its specific module, for example, the NN module, the Optim module, data module, and all. There is also Torch Vision library here. It is primarily used for image related applications, so we can apply different types of transformations and all on the images. So as a summary, both PyTorch and TensorFlow, they use computation graphs, and Keras included within the TensorFlow framework is more comprehensive. They have a bigger set of operations and modules and libraries available, and PyTorch, but is more flexible. It has better support for GPU accelerations. So that is all for today's lecture. In the next lecture, we will discuss about the data pre-processing techniques, and we will discuss different types of pre-processing techniques from next week onwards. So thank you.